So that's why I have, this is my top term, this is over here, and then it's plus the 1 minus beta on this side.
That's your alpha I.
Yeah, this is my alpha I. So that's my mixture component, right? It's the fraction of this that belongs to the Thackeray Poisson.
So alpha I, the definition of alpha I is that's the fraction.
That's a mixture, right? So it's a mixture component, two choices.
With Thackeray
Thackeray,
over all
Trollope.
possible choices.
And in this case, what I'm saying is that for every example, it's 0.2 Thackeray. You know, x1 is 0.2 Thackeray. x2 is 7 Thackeray. I don't know, right? So every example has some alpha, and what that alpha is the probability of it belonging to Thackeray.
And then does that mean that, you know, it's like 1 minus that?
Then 1 minus,
yeah,
yeah, of course. Yeah,
Yeah.
yeah, they have to go.
A bit hard.
Yeah, I mean, if you were to, I mean, if you think about it, right, is what it would be P of TR, in which that would equal as P of TR over the entire case, so it would be, you would have A over A plus B, and then the other would be B over A plus B, right?
Right.
So. Yeah, and this is clearly a pain. Since like the whole class is here minus like 2 people.
Everyone gets full credit.
No. Yeah, the answers are, well,
When I do the
I
math,
mean, the
it's
intuition,
gonna
I
be
mean-
worthwhile.
The intuition's there, the rest is derivation.
yeah, it's a derivation. I mean, the thing's obvious, right? So, I mean, it's obvious that eta equals I equals 1 to m alpha I over m, right? That's not shocking, right? And then if you look at the lambda, it's essentially the weighted estimate of the survival rates averaged over the sum of the alphas, right? Yeah, it's so, I mean, the thing about it is the hardest part is writing this out. When you go to take the derivative, everything falls out pretty quick because you're taking the derivative with respect to, you know, eta, right? And most things have no eta components, right? So they just kind of fall out.
You also take derivative with respect to lambda.
You also take the respect to lambda, less falls out, right?
Those derivatives,
But it still does.
those derivatives, are you doing the partials at the same time, or are you doing the partials?
I do them separately. So I think you have to.
Yeah.
Yeah, it's a little tedious. It'll make you. It'll make you
check your work.
Might make you write some math.
Yeah, and maybe you'll, since I never was so pleased with the exam, I need to make you despise me a little otherwise. All right. Any questions?
And then for part E, the algorithm basically
Oh.
kind of follows what you're doing.
So the algorithm, so all it is essentially what you have to do is say there's an initialization step. There's some halting condition, which is just that the log likelihood doesn't change enough.
Right.
And then there's any step and an end step, and you just iterate.
So for the initialization, do you just say 0.5, 0.5, 1 over n?
So 0.5 makes sense for eta. And then for the lambdas, the most obvious thing to do is just take the average
Okay.
chapter length.
Yep. Across everything.
Irrespective of any, you don't know anything.
Yeah.
Right? So
Is it
that's
okay?
all-
Go ahead.
So I would say lambda Thackeray equals lambda Trollope equals
The average.
average chapter length, right?
General rule of
Of
thumb
every
is just
chapter.
Of
take the average.
Or what I,
Over, wait, a book or?
if you have information, well, you have no information when you start, what belongs to what, right?
Right.
So if you want, if it makes you feel happy, take a random partition and start there. But there's no real, unless you have a legitimate prior, you're just guessing anyway. So it really doesn't matter.
Throwing darts on a dartboard.
You're throwing darts. Blindly. It's not even scored or, there's better analogies probably. Okay. You are all excused.